Hi again. Today we're gonna see bending stress, shear center, and unsymmetrical bending. Okay, let's see that. First one is bending stress. What is bending stress? Okay, so we have already seen this diagram before bending and after bending. Yes, A, B are the two sections and this is the axis. If the bending moment acting like this means it will bend. So this is after bending. So you can see here the same here. But we need to take O as a point which is the intersection of these two lines. Just extend AB, CD up to O. ஸோ இதுக்கு முன்னாடி நம்ம பார்த்துருக்குறோம் இந்த ரெண்டு டயக்ராமுமே. இது வந்து பிஃபோர் பெண்டிங். இப்படி பெண்டிங் மூமெண்ட் வந்து ஆக்ட் ஆகிறப்ப இட் வில் பெண்ட் லைக் திஸ். இந்த மாதிரி பெண்ட் ஆகும். ஸோ இதில் பார்த்திங்கன்னா ஏபிசிடிங்கிறது தான் டூ செக்ஷன்ஸ். அந்த டூ செக்ஷன்ஸையும் நம்ம வந்து எக்ஸ்டெண்ட் பண்ணி விட்டோம்னா ஒரு பாயிண்டில் மீட் ஆகும். அதுதான் ஓ. ஓகே, so angle between these two sections are theta, and then the radius up to O to this N point, the neutral axis. So O to neutral axis will be R. Okay, then we need to take a layer EF between this layer, like between the neutral layer and the bottom of the layer. Okay, so you need to take EF below the neutral layer as at a distance y. ஸோ நம்ம இங்கே ஒரு லேயர் எடுக்கிறோம். அது வந்து நியூட்ரல் லேயருக்கும் இந்த கீழே இருக்க பாட்டம் லேயருக்கும் நடுவில். ஸோ இதுக்கு கீழே எடுக்கிறோம் அட் அ டிஸ்டன்ஸ் y. ஸோ இட் வில் பி லைக் திஸ் ஆஃப்டர் பெண்டிங். Okay, so we know the distance is y. Okay, here this EF, N dash and N dash, these are all same because this N dash is neither compressing nor tensioning. Okay, so it is remain unchanged. So it is almost equal to NN. ஸோ இங்கே வந்து இஎஃப் என்என் என் டேஷ் இது எல்லாமே ஈக்குவல். இது ரெண்டும் ஈக்குவல். ஓகே, இது எப்படி என் டேஷுங்கிறது நியூட்ரல் ஆக்சிஸ் ஆஃப்டர் பெண்டிங். ஸோ இது வந்து கம்ப்ரெஸும் ஆகாது, சுருங்கவும் செய்யாது, விரியவும் செய்யாது. ஸோ இட் வில் ரிமைன் அன்சேஞ்ச். இட் இஸ் ஆல்மோஸ்ட் ஈக்குவல் டு என்என். ஓகேங்களா? So these are all equal to this distance dx. I am just taking this nn distance as this two section distance as dx. So it is dx. Change in length which is equal to radius into angle. So we are saying the change in length will be equal to radius into angle. So you can see here N dash will be equal to radius into angle. This is not at all change in length. You can take like length which is equal to radius into theta. Okay, so N dash will be equal to R into theta. Okay, so here N dash will be equal to R into theta. For E dash and F dash. For E dash, F dash, it will be like R plus Y because we need to add this distance. So R plus Y into theta. Yes, you can see here E dash, F dash will be equal to R plus Y into theta because the radius of E dash, F dash is R plus Y. Okay, so we can easily write this thing as N dash, EF, NN. It's all same, which is equal to del x. So you can easily write del x will be equal to r into theta. Okay. Okay, change in length. So increase in length of layer EF. There is an increase, right? This is EF layer. It is increases E dash F dash, right? So the increase in layer will be equal to E dash F dash minus EF. Okay. So E dash F dash minus EF will be equal to, this one we know, R plus Y into theta minus R theta. So from this thing we can easily get Y theta. So increase in length will be equal to Y into theta, distance into angle. So we know increase in length. So we can obviously find strain. நம்மளுக்கு increase in length கிடைச்சிருச்சு. ஸோ அதனால் நம்ம ஸ்ட்ரெயினை ஈஸியாக கண்டுபிடிச்சிடலாம். ஸ்ட்ரெயினோட ஃபார்முலா வந்து increase in length by original. Increase in length by original, right? So we know that increase in length is y theta. Original theta is nothing but EF layer. So we know that EF layer is R theta, right? So y theta by R theta, which is equal to strain, will be equal to y by R. So this is bending strain. Obviously bending strain we know. Then stress means E, which is equal to strain by stress, right? So Young's modulus E will be equal to strain by stress. Sorry. E will be equal to stress by strain. Okay, it's not strain. E will be equal to stress by strain. So we can easily find stress is same and then strain y by r. So from this thing we can easily say stress which is equal to E into y by r. This is bending stress. Okay, so this is what? Bending stress. So from these two equations, strain and then stress, these two equations is directly proportional to y, distance from neutral axis, or we can easily say depth of beam. So the stress and strain of any layer is directly proportional to the depth of beam, or else a distance from the neutral axis. Okay, and here the variation of stress is always linear. You can see here sigma by y, which is equal to E by R, leads us to bending equation. So this is half of the bending equation. Okay. Then bending stress in unsymmetrical section. So we're going to find the bending stress in unsymmetrical section. What is unsymmetrical section? Normally in a symmetrical section, you can see here, this is the geometric center of the section. Okay, so it is symmetrical about y axis and also about x axis. So the neutral axis passes through the geometrical center of the section. So the neutral axis NA of this section passes through the geometrical center. So this is symmetrical section. Then what is unsymmetrical section? For an unsymmetrical section, it does not pass through the geometrical center. It's the main point. And then the value of y varies in top and bottom of the section. So you can see here the value of y varies in top and bottom of the section. Okay, so the value of y varies in the top and bottom of the section, and normally bigger value of y is used. So we can easily take, we will have two y's, means we can easily take the bigger one, the larger one, we'll take it and we will use it in the calculation. So இதில் பார்த்தீங்கன்னா சிமெட்ரிக்கல்னா ஜாமெட்ரிக்கல் சென்டரில் நியூட்ரல் ஆக்சிஸ் பாஸ் ஆகணும். அன்சிமெட்ரிக்கல் அப்படின்னா ஜாமெட்ரிக்கல் சென்டரில் நியூட்ரல் ஆக்சிஸ் பாஸ் ஆகாது. அது மட்டும் இல்லாமல் இந்த ஒய் வேல்யூ நம்ம ஒரு இடத்துல கண்டுபிடிப்போம் அந்த செக்ஷன்ஸ்லே. ஸோ டாப் பாட்டமில் கண்டுபிடிக்கிற அந்த ஒய் எது அதிகமாக இருக்கோ அதை தான் நம்ம வந்து கேல்குலேஷனுக்கு எடுத்துக்குவோம். ஓகே, as the neutral axis normally passes through center of gravity. நார்மலாகவே நியூட்ரல் ஆக்சிஸ் வந்து சென்டர் ஆஃப் கிராவிட்டியில் பாஸ் ஆகும், பட் ஜாமெட்ரிக்கல் சென்டருக்கு பாஸ் ஆகாது. Okay, the center of gravity is calculated first. So first we need to find the center of gravity because the neutral axis is passes through the center of gravity. Okay, let me explain this thing in a sum. Okay, so first problem is a cast iron bracket subjected to bending. Okay, so it has subjected to the bending, has the cross section of I form. So it has the cross section as I form. Okay, with unequal flanges. So this is flange. Okay, there are two flanges in the I section, and this one, the middle one, is web. So it has unequal flanges. The dimensions are shown in the figure. Find the position of the neutral axis and then moment of inertia of the section about neutral axis. So we need to find these two things. If the maximum bending moment of the section is given, then determine the maximum bending stress. And what is the nature of the stress? So we need to find these things. Okay, so here you can see here, this is the bracket. So they have given this bracket, this is an iron bracket, and they have given the section as, if you cut it like this means, and you need to look like this. So if it cut it and look like this means, it will give an I section here. So you can see here, these are the two flanges. So this is web, and these two flanges are unequal. So they have given the dimensions, breadth, depth, breadth, depth, breadth, depth. So they have given the section, the dimension of the section. So we need to divide this section as 3 parts. Okay, then only we will get an easy calculation. Okay, okay. So the first thing is, they have given the maximum bending moment. Okay, then we need to calculate the center of gravity, that is y bar. So the y bar, the formula is a1y1 plus a2y2 plus a3y3 by a1 plus a2 plus a3. I am just dividing this section into 3 parts, 1, 2, 3, as a rectangle. You can see here, this is one rectangle, this is one rectangle, and this is one rectangle. Okay, so I am just dividing into 3 parts. In the section, I am 3 parts, 3 rectangles divide panikirom. So the formula will be a1 y1, a2 y2, a3 y3, a1 a2 a3. We need to add this. Okay, if I had the fourth part means, we need to include a4 y4, and in the bottom section, like in the denominator, you need to add a4. Okay, so this is what the formula. I am just taking from the bottom because we need to take this y1, y2, y3 either from top or from bottom. So I am just taking this from bottom. In the y1, y2, y3 ங்கிறதெல்லாம் டிஸ்டன்ஸ்ங்க. நீங்கள் இதை வந்து டாப்லேருந்து எடுக்கலாம், இல்லை பாட்டம்லேருந்து எடுக்கலாம். ஸோ இங்கே நான் வந்து பாட்டம்லேருந்து எடுக்கிறேன். ஓகேங்களா? So this is a section. So I am just taking from bottom. So from this to the center point of this triangle is y1. So இது வந்து நம்ம இப்போ 50 அப்படின்னா, the center point of this section na 50 by 2, right? So this is what y1, 50 by 2. Okay, அதுக்கப்புறம் பார்த்தீங்கன்னா y2, இந்த y2 பார்த்தீங்கன்னா இந்த distance, இந்த second rectangleக்கு சென்டராக இருக்கணும். So this y2 will be the center of this second rectangle. So we need to add this first rectangle y1, and then we need to divide this second rectangle. What is the depth of second rectangle? 200. So y1 plus 200 by 2 will be the center. y1 plus 200 by 2 will be the center for the y2. And then y3. So this y3 is the center for the third rectangle. Okay, so third rectangle. So we need to add y1 plus y2, okay, and then y3, the center of y3. So I can easily say y1 plus y2 plus this 50 by 2, 50 by 2. So these are the distance, okay, and we know the area. Area means for the rectangle L into B. So I can easily say L into B and then L into B and then L into B. So we can easily add A1, A2, A3 here. So just substitute all the values y1, y2, y3 and a1, a2, a3 in this formula. You will get the value as y bar, which is equal to 166.51 mm. Okay, so this value is from the bottom because we are taking from bottoms, right? The distance are from the bottom, right? So y bar is also from bottom, 166.51 mm. So from bottom up to here it will be 166.51. What is the remaining value like y bar at top? Y bar at top means just you need to subtract this value from the whole. Whole means 200 plus 50 plus 50, that is 300. Okay. So 300 minus this value will be 133.49. So we have found the center of gravity from top and the bottom. Okay, so in these two values you need to take the higher values. ஓகேங்களா ஸோ இந்த y1 y2 y3 a1 a2 a3 இதெல்லாம் சப்ஸ்டியூட் பண்ணுறப்ப நம்மளுக்கு y பார் வந்து 166.51 வருது. பட் அது வந்து லோலேருந்து, அதாவது பாட்டம்லேருந்து நம்ம எடுக்கணும். பிகாஸ் எல்லா வேல்யூஸுமே நம்ம பாட்டம்லேருந்து தான் எடுத்திருக்கோம். ஸோ 166.5 இஸ் ஃப்ரம் பாட்டம் and the remaining value கண்டுபிடிக்க, அதாவது டாப் கண்டுபிடிக்கிறதுக்கு the total minus the bottom will get top. So top is 133.49. நார்மலாக 2-3 y இருக்கும்போது நம்ம highest y தான் எடுத்துக்குவோம். So the highest y is 166.51. Okay, and the next step is moment of inertia, right? So we need to find the moment of inertia. As you know, the section is divided into 3 parts. So I will be equal to I1, I2, I3. Okay, I1 will be equal to moment of inertia of bottom flange at an axis passing through the center of gravity. So we need to find the moment of inertia for the first rectangle, that is bottom rectangle. Okay, so they are saying the axis passes through the center of gravity. So first we need to add the two things. Axis passes through the center of gravity plus a into distance of its center of gravity from neutral axis. Okay, so normally the axis passing through the center of gravity means we can easily write it as BD cube by 12. So this is the formula for this rectangle plus A1, that is area 1, into distance of center of gravity from neutral axis, that is H1 square. H1 means y bar. This is y bar, right? So y bar minus y1. Y bar minus y1 means this distance y1. So y bar minus y1. And the second thing, y bar minus y2. This is for H2. Okay, it will go like this. So first one வந்து axis passes through the center of gravity ன்னு சொல்லியிருக்காங்க. ஸோ அதோட ஃபார்முலா பார்த்தீங்கன்னா BD cube by 12 plus அதோட ஏரியா A1 into distance of a center of gravity from neutral axis. So distance of center of gravity from neutral axis, that is H1. So center of gravity is this and neutral axis. இதோட neutral axis பார்த்தீங்கன்னா y1. So இதோட distance. ஓகேங்களா, ஸோ அப்போ நம்ம எப்படி எழுதலாம், y bar minus this y1, we will get the distance, right? So y bar minus y1. ஓகேங்களா, so just substitute all the values and you will get the answer as I1 will be equal to this one, 1315.17 into 10 power 5 mm4. Same here, BD cube by 12, this is center of gravity for rectangle, plus A2 because we are considering the second rectangle into H2 square. H2 square means center, neutral axis. So this is y2. Okay. So center of this rectangle. Second rectangle is neutral axis y2. So we need to subtract y2 from y bar. Okay, that is h2. So h2 அப்படிங்கிறது h2 அப்படின்னா y barல இருந்து நம்ம செகண்ட் axis ஓட செகண்ட் ரெக்டாங்கிளுக்கு ஆக்சிஸ் வந்து நியூட்ரல் ஆக்சிஸ் வந்து y2. ஓகேங்களா. ஸோ y பார்லேருந்து இந்த y2 எடுக்கிறப்ப நம்மளுக்கு டிஸ்டன்ஸ் சென்டர் ஆஃப் கிராவிட்டிக்கும் இந்த நியூட்ரல் ஆக்சிஸ்க்கும் எவ்வளோ டிஸ்டன்ஸ் இருக்குங்கிறது தெரிஞ்சிடும். ஸோ அதுதான் அப்படி நம்ம பண்ணி உள்ள தூக்கி எல்லா ஆன்சரையும் சப்ஸ்டியூட் பண்ணிட்டீங்கன்னா 336.05 into 10 power 5 mm per 4. அதே மாதிரி சேம் I3 will be 1197.84 into 10 power 5. So just add all the things and you will get the answer as 2849.07 into 10 power 5 mm per 4. So the second part is finished. We have found moment of inertia. Okay. So this is an important topic actually. So I'm just writing it in middle of the sum. Okay. Moment of resistance. What is moment of resistance? Normally we have know that stress will be equal to E by R into Y. So we have found in the previous thing. Okay. So this is the thing. Stress is normally which is equal to load by area. That is force by area, right? So here in a rectangle, just take a single layer. So the distance of the single layer is dy and it is y distance from the neutral axis. And the area of this single layer is dA. Okay. So stress, load which is equal to stress into area. Just write load is equal to stress into area. So load which is equal to stress into area. Here stress is nothing but E by R into Y. And area is the small area dA. So force on that layer we have found it. And after that moment at neutral axis. So there will be an moment. So moment about the neutral axis will be equal to force into distance. Yes, normally the force kilonewton into distance meter, we will get the moment, bending moment. So force into distance. So moment which is equal to force is what? This is the force E by R into Y into dA. What is the distance? Y is the distance. So by doing so we'll get E by R into Y square into dA. So this is what distance. And this is for a single layer, right? Single layer. So we need to find for the whole section. So moment of resistance or the total moment on the whole section will be equal to, just take the integral E by R into integral Y square into dA. This integral part is nothing but moment of inertia. So we can easily write M which is equal to E by R into I. So we have found another relation. Okay. So we know that M by I will be equal to E by R will be equal to sigma by Y. So this is the relation. Okay, this is the simple bending equation. Okay. So this is the bending equation and this equation is applicable to the member which has constant bending moment and no shear force, that is pure bending. So this equation is applicable to the member which has the pure bending. Okay. So let's just move to the sum. So we know Y bar from bottom and top. So I'm just taking the biggest one. So 166.51 mm. Okay. And we know the relation. Just now I have told you this relation. So just to take these two parts. M by I will be equal to sigma by Y. M we know that because they have given the bending moment. So 40 into 10 power 6. Okay. From this thing just we need to find the stress. We know Y, I and M. Just substitute all the values, you will get 23.377 Newton per mm square. So this is what? The bending stress, maximum bending stress. This stress is from bottom. So bottom means compression. So stress at compression will be equal to 23.377 Newton per mm square. So we can easily write the diagram like this. Compression is here and tension is here. Compression means negative, so it will be like this, and positive, okay, this is negative. So we can easily write the stress diagram. In case of cantilever beam, because we have seen in the summer cantilever beam, so top layer, that is upper layer, will be tension and the lower layer will be compression. So likewise it will be compression here and it will be tension here, okay. And the next part is shear stress in beam. So we have seen the bending stress. Then what is shear stress? In bending stress, the bending moment is constant and shear force is 0. That is pure bending. Okay. In this part, the shear force is 0 means shear stress is also equal to 0. If shear force is there, then shear stress will be there. If shear force is 0, then shear stress will be 0. So நம்ம இப்போ பார்க்குறது shear stress. Bending momentல the bending moment கான்ஸ்டண்ட்டாக இருக்கும், shear force 0வாக இருக்கும். இது நம்ம பார்த்துருக்கோம். ஸோ shear force வந்து 0வாக இருக்குன்னா ஆப்வியஸாக shear stressம் 0வாக இருக்கும். If it has some numbers, this is also varies according to the shear force. Because shear stress, which is nothing but shear force by area. அதனால தான் shear stress வந்து shear force பொறுத்து proportionலாக இருக்குது டைரெக்டாக. ஓகேங்களா. ஸோ இன் ப்ராக்டிக்கல் the bending moment in the beam is varies. It does not attain the pure bending. And the shear force is also varies. So we can obviously say the shear stress in the beam also varies from one place to another. Okay. First one, how the shear stress travels. The first thing, the shear stress act along the transverse section. Like this section. So this is the beam means it will act along the transverse section. These transverse shear stress will produce horizontal shear stress along the longitudinal layers of beam. Okay. So we have seen this is the beam and transverse shear section is acting. Due to this, it will produce horizontal shear stress along the longitudinal layers of the beam. So these are the layers of the beam, longitudinal layers. So it will produce horizontal shear stress along the longitudinal beam. So thus the beam will subject to the shear stress. So this is what the shear stress. And the next one is shear center. A point through which applied shear force does not produce any torsion or twist. ஒரு பாயிண்ட் இருக்கு, ஸோ அங்கே வந்து நம்ம ஒரு ஷியர் ஃபோர்ஸை அப்ளை பண்ணுறோம். இந்த பாயிண்டில் எந்த விதமான ட்விஸ்ட் நடக்காது, ட்விஸ்ட் ஆர் டார்ஷன். அந்த பாயிண்ட்டை தான் நம்ம ஷியர் சென்டர்னு சொல்கிறோம். ஸோ a point through which a force is applied. So the force is applied to the point and at that point there is no twist or torsion. So we can directly say that point is shear center. And if the load is applied at shear center, so they are saying any load is applied at the center, it will produce twisting or torsion to the beam due to the unbalanced moment. So they are saying, so this is the point at which no twist and torsion is applied. So is formed due to the applied shear stress, shear force is called shear center. ஓகேங்களா. ஸோ டார்ஷன் ட்விஸ்ட் அது ரெண்டுமே இந்த பாயிண்டில் நடக்காது நம்ம அப்ளை பண்ணுற ஷியர் ஃபோர்ஸ்னால. ஸோ இட் இஸ் shear center. So we are applying a load in this shear center means it will produce twisting and bending moment, twisting and torsion to the beam due to the unbalanced moment. So unbalanced momentனால அந்த பீம் வந்து ட்விஸ்ட் டார்ஷன் வந்து ப்ரொடியூஸ் ஆகும் நம்ம ஒரு லோடை இந்த ஷியர் சென்டருக்குள்ளே அப்ளை பண்ணுறப்ப. ஓகே. These unbalanced movements these unbalanced movements are caused by the shear force acting on it. Okay, so this is what shear center. Normally the shear center lies on an axis of symmetry. If the section is symmetrical about one axis, we have seen that it is symmetrical about y axis. Yes, we have seen this in previous problems. And it is symmetrical about x axis. So likewise, we can easily say it should be symmetrical about one axis, means then we can easily say the shear center will lie on it will lie on the axis of symmetry, either y or x. It depends on the section. Okay, so in the shear center இப்போ y axis symmetrical about y axis, symmetrical about x axis அப்படின்னு இருக்குன்னா இந்த shear center will lie on axis of symmetry. If it is lying on axis of symmetry but it does not coincide with the centroid, அதோட centroidோட coincide ஆகாது because it is symmetrical, the section is symmetrical about one axis. So symmetrical about any one axis means it does not coincide with the centroid. So ஏதா ஒரு axisல மட்டும்தான் அந்த section symmetricalா இருக்கு அப்படின்னா அதோடைய shear center will not coincide with the centroid, அதோட centroidோட coincide ஆகாது. Whereas shear center lies in the intersection of two axes if the section is having two axes of symmetry. அதாவது the section is symmetrical about y axis and symmetrical about x axis means the shear center will be lies in intersection of these two angles. So it will be like this, intersection of two axes of symmetry, and it also coincide with the centroid. So there are two things here. The section is symmetrical about any one axis means the shear center will lies in any one axis and it does not coincide with the centroid. Whereas the section is symmetrical about two axis means the shear center will lie in the point of intersection of these two axis and it also coincide with the centroid. So shear center உடைய position பார்த்தீங்கன்னா இந்த section symmetrical about one axis இல்ல two axis. So symmetrical about x or y or symmetrical about x and y. இதை பொறுத்து தான் shear center இருக்கு. ஓகேங்களா, ஏதா ஒரு ஆக்சிஸ்னா அந்த ஆக்சிஸில் தான் இந்த ஷியர் சென்டர் இருக்கும் அண்ட் இட் டஸ் நாட் கோயின்சைட். இதோட சென்ட்ராய்டோட இது கோயின்சைட் ஆகாது. ஒருவேளை the section the section has symmetrical about two axes அப்படின்னா the shear center lies between the intersection point of these two sections and it also coincide with the centroid. இது centroid கூடயும் coincide ஆகும் and இந்த ரெண்டு section axis of symmetry ரெண்டுமே மீட் பண்ற intersection pointல தான் shear center இருக்கு. Okay, and the next one I'm just giving the introduction part for the pressure vessels. Okay, so we will see the detailed things in the next video. What is pressure vessel? The pressure vessel means the vessel which is used for the compressed air receivers or any boilers etc. So the pressure vessels பார்த்தீங்கன்னா இந்த air compressed air receivers ஆவோ இல்லைனா boilers ஆவோ நம்ம யூஸ் பண்ணுறோம், நிறைய யூசேஜ் இருக்கு. And main the pressure vessels will be either cylindrical or spherical. The pressure vessels பார்த்தீங்கன்னா either cylindrical இருக்கலாம் spherical இருக்கலாம். So pressure vessel is mainly used to store liquid or gases under pressure. So நம்ம liquidயோ gasயோ store பண்றோம் under pressureல. So அதுக்கு தான் அதுக்கு நம்ம யூஸ் பண்ற vessels தான் pressure vessels. And their walls are thin as compared to their inner diameter. Like if I say this is outer diameter and this is inner diameter, it is either cylindrical or sphere. So I am just taking the cylindrical here. So you can see here this is cylindrical portion. So the thickness, இதோட thickness பார்த்தீங்கன்னா இதோட inner diameter விட கம்மியாக இருக்கும். ஓகேங்களா? So their walls are thin as compared to their inner diameter. Okay, so what is thin cylinder? Thick of thin cylinder, thickness. Okay, so the thickness of thin cylinder will be less than 1/15 to 1/20 times of its inner diameter. So நம்ம என்ன சொன்னோம், இதோடைய thickness வந்து inner diameter விட கம்மியாக இருக்கு சொன்னோம். அது எவ்வளோ கம்மியாக இருக்கும்னா 1/15 to 1/20 times. So this is what thin cylinder. So normally in case of thin cylinders, the stress will be uniform throughout the section. Okay, so I'm just giving a little introduction about the pressure vessels. Okay, so we will see thin thick cylinders in the next chapter, like in the next video. Okay, so thank you so much for watching this. Do watch all the videos and give your suggestions to the videos. Thank you so much. Bye.